Good morning, everyone, and thank you for joining us. This is Sarah Davison with Viavi Solutions Marketing. I would like to thank you all for joining our call today on saving time, money, and lives with communications test. I have just a few housekeeping notes to share with you. This webinar is being recorded and will be available for you in approximately 24 to 48 hours, and an email to all attendees with a link with the recorded version will be sent out. All lines are on mute, but we are monitoring the chat and will answer questions at the end of the webinar or reach out to you individually to ensure you get the answers you seek. And now I'd like to turn it over to our speaker today, Dave Hansen.
Hello and welcome to today's webinar. I see we have people signed in from around the world, actually. I have some people signed in from Taiwan, so welcome, Bart. I do want to welcome everyone to today's webinar, and we are going to talk about how we can be better at what we do with testing of our radios and our radio systems. So before we get started in the meat and potatoes, I wanted to talk about the little control panel there that you have for GoToWebinar. At the bottom part of the screen, or you'll see the little box that says enter a question. If you have questions, we will probably do a short Q&A at the end, try to answer a few of those questions, but I think we're going to try to focus mainly on the content, and then get back to you if you have questions after the webinar offline. We'll shoot you an email or give you a call, contact you afterward to address any questions you have. Please do feel free to ask any questions that come up, either for the webinar or other things, as that's why we're here. We do want to address any questions or concerns you have. The other thing we've had in the past is sometimes people have problems with the audio. There's a section here at the top of that control panel that where you can go through your controls and check your audio, make sure it's working. Most of the time we find that it's settings in the computer that cause the problem, either the audio set to headphones that aren't plugged in, or set to the speakers that aren't plugged in, so check those things as well. Okay, well, let's get started. My name is Dave Hansen. I have been a solutions engineer here for, well, a while. We'll just say a while. I've been with the company for 21 years, and supporting radio test sets. So like the farmer's commercial says, we know a thing or two because we've seen a thing or two. So between myself and the rest of the team, we have quite a bit of experience. And again, if you have questions that pertain to radio test, we would encourage you to get in touch with us and ask any questions that you do have. So let's start out with a question for you, actually. This isn't something you have to answer. It's not something that I guess you need to respond to, but I want you to think about it. I want you to think about this question as we go through today's topics, and how those things affect how you would respond to this question. So what does LMR network unreliability cost? And you know, there's a cost associated with reliability in a network and maintaining that network. But just like there's a cost associated with maintaining it and keeping it up and running, there's also a cost associated with not being able to, or not maintaining that system as it needs to be, and having to perform remedial maintenance and all the peripheral effects of that. So what does LMR network unreliability cost? And I've got a few little things here that you might answer. These might be your answer for that question. First one, system downtime. If you aren't maintaining your system properly and keeping it up to par, you could experience unexpected downtime. And of course, with downtime comes huge inconvenience for our customers, our users. In some situations, it can be worse than that, worse than inconvenience. So system downtime is a potential cost of an unreliable network. Technician overload. Technician overload is something that occurs if we have a set amount of work to do, and we have the right amount of technicians, right number of technicians to do that work, and then we have unexpected maintenance that occurs or is needed. Those technicians can become overloaded, and of course that has many effects. There's just simply the stress of having to do more than you have time for, and then of course there's the effects of that on the rest of the team that maintains that equipment, and then of course the customers who are relying on those technicians to be at their best and to perform their duties to the utmost of their ability. So technician overload can be one of those costs associated with unreliability in an LMR network. Third thing I want to talk about is cost. So money. Lots of things revolve around money, and really, I suppose you could even roll that system downtime and technician overload into that response as well. Of course, there's immediate direct costs associated with unreliability, such as having to replace equipment, having to possibly rent equipment to replace the equipment that we have that's down. You may have to expedite shipment or expedite processing of an order for parts to repair a system. Those things all cost money. Technician overload plays into that, because if you have more work than your technicians can do, you may have to sub out some of that work. You may have to hire temporary technicians. You may have to hire someone permanently. You may have to pay overtime. And of course, that all affects our bottom line as well. So from a money standpoint, there are many different aspects that play into that, some of them direct and some of them indirect. But there's that adage that says an ounce of prevention an ounce of prevention is worth a pound of cure. And in this situation like this, that couldn't be truer. We can spend a certain amount of money maintaining a system, keeping it up and running, keeping it operating in optimum shape, or we can spend more money to bring it back up to operational status when it goes down. So that's something that's always at the forefront of our minds. Now, as important as money is, and as frequently as that becomes a deciding factor in what we do in our lives, as we're maintaining equipment, a lot of times, unfortunately, we have to consider the cost of maintaining that equipment at the time. Our budgets are limited, and there's still work to be done. There's still maintenance that has to be done. So we have to balance those two. But one of the other, and this is probably, I would say, the biggest cost associated with network unreliability, is lost lives. So our title is part of the title is Save Lives Through Communications Test. And that's exactly what we can do here. By maintaining our systems properly and keeping them up and running, keeping them operating properly, we can save lives. If you have a first responder who's unable to communicate with dispatch and say, get a correct address for a patient, they could end up going to the wrong address. And meanwhile, that person is suffering somewhere. Firefighters could be in a similar situation where they need to be able to communicate outside of the building that they're fighting a fire in. And if they're not able to communicate with their supervisor or other firefighters, their lives could be put in danger. So there are many aspects of many ways that our lives are affected by network unreliability, and none of them in a good way. So there's one other thing I want to add up here. Lost livelihood. So I talk about lost lives, and of course, obviously, we don't want anybody to lose their life due to an inability to communicate with supervisors, with dispatch, with other coworkers, that sort of thing. And so, we always consider those mission critical communication systems to be important. We always say, well, those are the utmost importance. We got to keep those up and running because someone's life is depending on it. I think when we do that, sometimes we kind of dismiss the importance of non-mission critical or non-public safety communication systems. So even if you're not maintaining a system for a police department or fire department, first responders, a military organization, if you're just, let's say you're maintaining communications for just some commercial enterprise, that could be a ballpark, it could be a construction company, school buses, anything like that, it may not have the same impact as someone losing a life, but to the person who's depending on that radio to perform their job, to keep their customers happy, if their network is unreliable, to them, it's still important. So if we take put some blinders on and say, well, just within the scope of this one individual's business, they're relying on their radios to be able to communicate with their technicians. They're relying on those radios to communicate with other coworkers, to coordinate logistics and that sort of thing. If they're not able to do that, they have the potential to lose business, lose revenue, and of course that's going to reflect negatively on us if we're the ones that let that system become degraded or let that system fail. So lost livelihood, even though it's not the same as lost lives, to the people who it affects, it is still very important. So we're going to start out talking about coverage, and again, I want all this that we go over to give you something to think about as we look back on that question. The cost of network unreliability. So we're going to talk about coverage here and how things we can do that will affect that coverage, improve it, verify it, etc. Talking about indoor coverage. So International Fire Code says that we need to maintain a certain level of signal strength across the entire building, well, 95% of the building. Additionally, we need to be able to communicate from inside the building out. And of course, that has to do with first responders, firemen, anybody who's in there inside the building needs to be able to communicate with people outside of the building and vice versa. There's ways that we can check that. The method that I prefer, and again, multiple ways of doing this, there's predictive software, but at the end of the day, we have to be able to verify that signal strength meets those requirements. You can use a system like the TRX Neon application, which lets us go in and map that software or map that signal strength using their software. That allows us to record the signal level at each of many points throughout the building, and then generate a heat map or a pass-fail map showing where it's good, where it's bad. We can do that prior to building being opened up, prior to a certificate of occupancy being issued, and determine if in fact it does meet those requirements. If it doesn't, then we can go in and we can do things like install a BDA and DAS. We can do other things to try to bring that signal level up. There's also, and this kind of comes back to the need to have the right test equipment, being able to do things in the right way. With the proper test equipment, we can actually verify not just the signal strength, but we can also verify that the signal quality is good. And there's multiple ways of doing that as well. But if you have the right test equipment, being able to measure and quantify that digital signal that is being received inside of the building lets us verify that whoever's inside can talk to whoever's outside and vice versa. So we take a baseline prior to the installation of a BDA and DAS, and then once that's installed, we can go back and verify that it did address the weak areas that we needed to address. So we can once again take our software, our mapping software like the TRX Neon, walk through the building, verify that it is in fact brought up to that minimum of negative 95 dBm. We can verify that the signal quality is good, and now we have a baseline for future measurements. Then, in the event that something occurs, some sort of degradation occurs, someone complains, says, hey, we can't communicate in this part of the building, we have something that we can refer back to and say, well, this is what it was when the building went up. Let's go back in and remeasure and see what has happened. And then that information, that data can be used to troubleshoot those types of issues. Another thing that can be done is if we have that baseline data, we can actually go back and perform periodic maintenance and remap that building periodically to make sure that there aren't areas that are becoming degraded before it happens. That's one of the things that is key to maintaining a system and maintaining its usefulness and its effectiveness is that preventive maintenance. So going back and verifying that things are working before someone tells you they're not. That's not something you, again, talking about public safety and mission critical systems, we don't want to find out that it's not working because it didn't work when it needed to. We want to be able to catch that before it happens. So being able to go back through a building and verify that BDA and that DAS is doing what it's supposed to do and we are maintaining those levels can be very helpful in identifying problems before they cause bigger problems. Now, there are many different things that can cause a reduction in coverage inside of a building. We'll talk about a few of these, and I don't know if this is all inclusive, but these are a few of the things that can happen. We have man-made causes, and that could be things like new construction, maybe some remodeling that got done, and they put up a new wall, and now it's blocking a signal that we used to be able to receive. It could be things like cut cables. I don't know how many people I've talked to over the years that have been working on a construction project, and they show up and install their system, and then prior to certificate of occupancy being issued, someone says, well, hey, we don't have any coverage in this part of the building, and they go back and remeasure it, and sure enough, there's nothing there, only to find that somebody has cut one of their cables inadvertently when they maybe cut down some bracing or something like that. I've also had situations, talk to customers where they have gone back into a building that was fine. It was fine for years, and then some remodeling or some plumbing work was done, and the antennas were in the way. So rather than contact them and say, hey, what can we do with these antennas? The crew that was in there putting that plumbing in just took all the antennas down. So many types of man-made problems can occur. Natural causes can be anything from minor to significant. You could have a natural disaster like a tornado or a hurricane that destroys an antenna or takes down part of a transmission line. You can have things like water ingress into connectors. And of course, that typically would happen more slowly, and so you'd see a gradual decline in performance of the system. Just the natural aging of components can sometimes cause equipment to fail. So many different natural causes. And I'm going to jump past equipment degradation for a moment and skip to interference. Interference is something that is kind of out of control a lot of times. We have to respond to it most of the time. Unfortunately, that's becoming more and more common as we see more, for example, more band 14 LTE signals pop up. People are having trouble testing their radios in those situations because of that interference. Of course, the band 14 goes up into our 700-800 megahertz band up to 768 megahertz. And so if you have channels in that frequency range, and that's the downlink, of course, from the tower, so it's going to be the higher power level, that is going to have an effect on our measurements. And sometimes that can interfere with our communications as well. So interference can be a problem, and it always has been, but I think it's going to become worse as time goes on in certain areas. So equipment degradation, that's one of the things that we do have control over. So again, there's things we don't have control over that we have to respond to, but equipment degradation is one of those things that we do have some control over. We can go in and we can maintain that equipment. We can perform preventive maintenance. We can perform periodic maintenance, verifying, aligning, making sure that equipment is working in its to its best capabilities, so that it doesn't impact the end user in a negative way. We'll talk more about the alignment of radios and how we can do that efficiently in a little bit, but let's jump to outdoor coverage. And we're going to see a lot of kind of overlap, I think, with the indoor coverage things that we just talked about. So again, with outdoor coverage, we can still do the same things with mapping an area. Instead of walking through a building now, we can use maybe a GPS-based mapping algorithm, mapping software to quantify our coverage in a given area. We could use something like the STI Field Test 7 software, for example, to go in and do that. And that gives us, again, before we have sites go up, we can do that to establish a baseline. And then after that site goes up, we can always go back and then verify that our coverage is what we expect it to be. If, once again, there are areas that people are having difficulty communicating in, we can go into those areas and quantify, again, that coverage in that area, make sure that the coverage is what it was supposed to be. And this is where we can use that for troubleshooting. We can say, well, it's not system-wide, it's just in this one area. So then we can look at what would affect that one area. So just like with the reduction in coverage in building or indoor situations, outdoor coverage has much the same type of impact by those things we talked about before. So again, with man-made causes, we have things like obstructions. New building goes up, a bridge, something like that is constructed, and it causes maybe an obstruction. Especially if you have an area that is already kind of weak, has weak reception. It doesn't always take a lot of obstruction to be able to impact that and cause the coverage to drop significantly. So multipath is another thing that I think a lot of times is overlooked. It's easy to look at a situation and say, well, the signal level is low, so obviously that's the problem. But if the signal level is fine, then we start looking at other things. Well, is our programming right? Is something misaligned? Is there some other sort of failure But multipath, I think, frequently gets overlooked, and it can cause some very strange behaviors. You can have a spot, an area where coverage is good in most of that area, but in just certain spots, because of the phasing of the signal, in certain spots you have dead spots, and so because of that, it makes it sometimes very difficult to identify what's causing it. And again, you go back in there with a spectrum analyzer, and you go, well, the signal level's fine, but here, having the right equipment, being able to go in there with the right equipment and measure the actual signal quality, we can find sometimes that, well, maybe there's some other things happening because our signal quality is not what it should be, and that's why the receiver is not receiving the signal like it should. So multipath obstructions, again, you can still have all those other things we talked about, like cut cables. We can have malicious or not malicious things happen. People like to go out and shoot at towers for target practice. And so we have to have tower crews come out and replace coaxes going besides the towers. Things like that happen. So lots of different man-made causes, natural causes. Once again, same types of things. You can have catastrophic failures like an antenna being damaged by lightning, or a radio transmitter damaged by lightning. You can also have more subtle, more gradual things like water in connectors and cables and things like that. So lots of different causes. And then again, with interference and degradation, those two things, just like with indoor coverage, we can do some things to mitigate that, like the equipment degradation. We can do the maintenance that we need to do. Interference, we're kind of responding to it and kind of chasing and trying to identify and remedy it as well as we can. So there's some obvious things that affect coverage. I talked about bridges or new walls or new buildings going up. Interestingly, misalignment of radios is probably a more common cause. Obviously, those things do happen. We do have lightning strikes. We do have cables that get closed in doors or have staples driven through them and things like that. But a more widespread, maybe I shouldn't say more often, but a more widespread thing that happens is our radios are misaligned, and that can happen through aging of the components. It can also happen due to misalignment because of not using the right equipment. We've had situations where customers have said, well, we aligned our frequency, our reference oscillator on our radio, but now it's off by 150 hertz. What happened? And that goes back to having the right equipment. We'll talk more about that in a little bit, but the point is that we can affect the coverage area or the apparent coverage area by or through the alignment of the equipment. So if we have radios that are misaligned, it can appear that we have, for example, decreased sensitivity. So we say here that improper alignments can cause degraded digital modulation accuracy, and that's true. When we start talking about digital radios, and a lot of us I know are still transitioning to digital radios right now, a lot of analog still out there, but a lot of us are starting to transition, more of us are starting to transition over into digital radios, be that DMR, Tetra, NXDN, DPMR, P25. And when that happens, we have to kind of shift our mentality. So one of the key things that can happen with a radio receiver ability is if our digital modulation is not correct, again, that has the same effect as a reduction in power. So, and by that, a reduced coverage area. So this is going to affect both subscribers and repeaters, base stations alike. If something's off frequency or something has improper modulation, it's going to affect both sides of things. And oftentimes when that happens, it's difficult to tell whether it's the transmitter or the receiver. So again, having the right test equipment, we can verify that the transmitter is transmitting the right signal and that the receiver is receiving that correct signal correctly. Again, alignments. Alignments are the key thing to this. Making sure that our deviation alignments in analog are correct so that when we do switch to digital, all of the digital modulation is correct as well. Now, here's what that kind of looks like. If we take a look at the coverage area for a 100-watt transmitter here. You see the dark blue area there, and then of course there's the lighter purple area around that. If we were to drop that power by 3 dB, you'll see that the dark blue area gets smaller, meaning that our coverage area is now getting smaller. And if we drop it another 3 dB, so now we're 25 watts, so 75% lower than we started out, you can see, of course, that the coverage area is significantly smaller. Now, that's what happens if we reduce the power that we're transmitting. If we misalign a radio so that the receiver sensitivity is affected, we can affect the receiver sensitivity by that same 6 dB. And now, somebody that was standing somewhere in that blue area on the picture to the left may not be able to receive that same signal, even though it's a good signal. If they're standing in the same area, it'll look something more like on the right. So in other words, our receiver sensitivity being degraded like that can effectively make our coverage area look smaller. So what can we do about those alignment related issues? Well, we can align our radios, and again, going from analog to digital, there's some differences in what we do and how we do them. In analog, we have a certain set of things that we look for. These are common measurements that we can do with common test equipment: frequency, modulation, power, and sensitivity. Those are things we can look at without a lot of complicated equipment. Thing is, with analog, we can get away with a lot of misalignment. So it's important when we go to digital then that we have the right equipment, because in digital, all those same measurements that we could kind of get away with being wrong in analog, now they become critical. So when we go to digital, we see some of the same things, frequency and transmitter power, but then we start seeing some different measurements. And if we don't have the proper test equipment, a digital radio test set to measure those things, we're not going to be able to verify that we've done it correctly. We're not going to be able to measure frequency correctly, for example. We're not going to be able to measure things like symbol deviation, where there is no analog equivalent. We're not going to be able to measure that. And so it's critical, in order to make sure that those radios are working correctly, that we have the right equipment. Now, one of the things I've talked customers about over the years, and things that this I run into quite a bit actually, is customers will say, well, you know, I got this radio in, I went through the alignment, everything looked good. I keyed the radio up and it got on the system, so I know it works. But my customer, when they go out into this area, you know, it's not receiving a signal. So we assumed that since the radio is working, that it must be a coverage thing. So we went out and we did a bunch of troubleshooting on the base station, or the repeater rather. We swept the antenna, we swept the transmission line. We did all this work out there, couldn't find any problem there either. What could be the problem? And so at that point, we can take a closer look at that radio with the right test equipment, with a digital radio test set. We can look at that radio, and we can see that it's actually, even though he did some maintenance on that radio, it's actually misaligned. So maybe the FM deviation is not correct. If the FM deviation is not correct in analog, the symbol deviation is not going to be correct in digital, and that can have a huge impact on the performance of that radio. If we measured the transmit frequency using an analog frequency meter, frequency counter, in digital, then it's quite possible that our RF frequency is actually skewed because of the way digital signals work. So it's important, and it's critical really, that we use the right equipment to test those radios. And now, because we're able to, with the digital radio test set, we're able to quantify that radio's performance in a digital mode. We can see that it's misaligned. So now we can address that. We can go in, we can align it properly with the right radio test set. We can properly align it. We can verify that it works. And now when we issue that radio again, we know that it's going to work in that area. Okay. So to summarize that slide, analog alignments are important, even when we're operating a digital radio. All of those digital parameters that we look at, or many of those digital parameters that we look at, are based on an analog alignment. And so it's critical, it's important that we perform those analog alignments correctly, accurately, using the right equipment. in light of that, the FM deviation meter accuracy becomes super important. Of all the analog parameters that we can affect a change to that will affect a digital change, a corresponding digital change, FM deviation is probably the most critical. When we're looking at that digital signal, and of course the purpose of this webinar is not to get into the weeds of digital modulation, so we won't, but when we look at that digital signal though, on our digital radio test set, we can see what we call symbol deviation, one of the parameters of that signal, and that is based on the analog alignment. So if we've misaligned the FM deviation because our FM deviation meter is not accurate, we can skew all of those parameters in digital. And because that FM deviation affects the symbol deviation, because symbol deviation is so critical to a digital radio's performance, we can drastically affect how that radio performs. So again, a digital radio test set is required for testing most of our modern radios, even though most of our modern radios are still an analog RF device, just being modulated in a digital fashion. It really comes back to being able to test it correctly in the digital mode to make sure that it's working. And once again, those digital parameters can't be measured with an analog meter because again, there's frequently, oftentimes not an analog meter equivalent to those digital parameters. So, we could manually test and align these radios to verify everything's working correctly. One of the reasons that doesn't happen in many instances, and this isn't necessarily, I guess I shouldn't say it's a bad thing about any particular technicians or shop philosophies or anything. It's just something that is worth noting, and I think needs to be addressed. Is that when we are testing things manually, it takes a certain amount of time to do that. I mentioned keying a radio, it gets on the system, so it must be working. As being one of those situations, and that's something that happens pretty often because people don't have time to go through and do a thorough, complete manual alignment of a radio. Time is critical, time is money. And so unfortunately, sometimes that means that people have to find ways to get more radios out. And one of the ways they do that, unfortunately, is cutting corners. So rather than going through a full alignment of that radio, full test, we're going to go through and we'll check a few key spots. Maybe we think the customer is using it on this channel, so we'll check the power and frequency on that channel, whistle into it, make sure that it comes out okay, make sure it gets on the system. And if it does, then we assume that it's okay, which, as we've already shown, may not be the case because you could get into a situation where in a weak area, that radio may not receive a signal like it should. So it becomes all the more important because of that to properly align and test these radios. And by that, I mean to thoroughly align and test these radios. But again, doing so manually takes time. And some of these radios, you could spend an hour going through the alignments on the radio. And that's in addition to any firmware updates or reprogramming that has to occur. And so if it takes an hour to go through a radio, and then you have to do all the programming and firmware updates on top of that, you could be talking about maybe getting 6 radios out a day or 7 radios out a day, which, in years past, we would look at that and say, well, I mean, that's just the way it is. Today, that's not necessarily the way it has to be. So we have the ability to automate that alignment, automate that test. And in doing so, we gain a lot of benefits. In addition to the obvious having it automated so a technician doesn't have to do it, we have things like this consistency. If we have multiple technicians aligning multiple radios, each of those radios is going to get tuned a little bit differently. Each of those radios may get tested a little bit differently because one person may key the radio up and go, well, the power's a little bit on the low side, but I think it's okay. I think it'll be okay. So I'm going to go ahead and issue that radio again. Another technician may look at the FM deviation and go, well, it's a little high, but I've been testing radios for 50 years and analog radios don't care if the deviation is a little bit high. So these digital radios should be able to deal with it just fine too. Yeah, out it goes. So you end up with situations where radios are not consistently aligned or tested, and some radios are going to perform well and some radios aren't. Let's go back to that situation where we have a first responder relying on that radio. We don't want that first responder to not be able to communicate because he got one of the radios that was a little on the weaker side, or he got one of those radios with a little bit more misaligned than another one. If you get used to a certain radio behaving a certain way, you may become accustomed to being able to receive a signal in a particular area, and then you get issued a new radio that's not aligned correctly or not aligned the same as the other one, and it doesn't work the same. So now you don't have that same coverage. Those are situations you don't want to be in. So consistency in alignments, consistency in these measurements and testing, is a lot more important nowadays than it was in years past. And again, with a manual process, you don't get that same consistency that you do when you have an automated process where a computer's running the show, computer's looking at those results and saying, yes, it passes, or no, it doesn't. It doesn't fudge numbers for us to get things to pass. Another thing that we can look at is that human factor. So we just talked about taking out that inconsistency. And that comes from the human factor, right? Because everybody looks at things from a different perspective. So if we take that out, combined with the more consistent measurements, things like transposing a number aren't going to happen. Somebody, a technician testing a radio, could see 2.5 watts, thinks it's 5.2, and we move on, even though the radio is putting out less than half the power it's supposed to. That sort of thing doesn't happen with a computer. It's going to see that it's 2.5, and it's not going to switch those numbers around, and it's going to fail that radio. So we have a chance to address that. So things like that don't happen. Things like skipping tests because we just got distracted. We were working on this radio and the phone rang and totally forgot to do the rest of the tests and alignments. That doesn't happen. So we remove that human factor. Another thing that happens, and this is something that, from a shop management standpoint can be real helpful, is it allows us to reallocate our technicians more effectively. So we can put our more skilled technicians, more seasoned veterans out doing the work that requires their skills, instead of having them on a bench trying to align radios because we've got X number of radios to get out and we just don't have enough people. So that's not to say that we're dumbing it down, but it allows the less skilled technicians to do these alignments and to gain some more familiarity with the radios and how they work without having to have that more skilled technician there babysitting them or doing the work for them. One of the key things that has come about in recent years is the need to document the testing that we do. And it's always been there, but I think it's become more important recently. I know some customers that save their test results and print them out for every radio that they touch, because if the agency that they're doing work for comes back to them and says, hey, we had a casualty because this person was not able to communicate, this is the radio that they had, why did you give them a bad radio? Having that documentation that you can rely on that says, no, we did test that radio, it did pass, and moreover, being able to test that radio again and verify it still works may be able to kind of keep you out of hot water. Not every situation is that cut and dry. Not every situation is that drastic, but being able to go back and say, look, no, we did test this radio. We've got test results, documentation showing we did that is nice. As a business, being able to provide that data to your customer to show them that you tested that radio, that's value added. That's something that you can say, look, if you take it to the radio shop down the street, you know that they're going to go through and manually test this thing, and they're going to hand it back to you and say, yeah, it works. Here, I'm giving you your radio back with documentation saying that everything passed, and giving you the values that we actually measured for each of those parameters. So being able to, like I said, being able to provide that extra data, in that situation is value added, or it may be something that you're able to charge more money for. most of the time, when we're testing radios with an automated, in an automated fashion, like for example, using Autotest on an 8800SX or 3920B, the test times are going to be quicker. The alignment times are going to be quicker. So what that means is that our technician is now going to be free to kick back and relax as he gets more radios out. So he's going to work more efficiently. He's getting more radios out during the day, and of course, from a 10,000 foot view, you can say, well, that's great because he's getting more radios out, so higher productivity. That's not always the case. Sometimes it takes about the same amount of time to align a radio fully in an automated fashion as it does for our technician to test the radio manually. But a lot of times when that happens, we're not really comparing apples to apples. So I talked earlier about, in order to get more radios out, one of the things that happens is we start taking shortcuts. We say, well, let's just skip some of these measurements because they're not real critical to the operation of the radio. Let's get the important things like power and frequency and modulation, and we'll check every 10th radio and make sure it's good for the other stuff. So maybe it takes 10 minutes to do that, and it takes Autotest 10 minutes to go through and do that same radio. But when Autotest does it, it's actually doing a full alignment of that radio, full test of that radio. So it's not skipping over any of that stuff that we had to skip over manually in order to maintain a certain pace through the shop. So I say we have quicker test times for most radios. That's true, but even in those instances where it's not, a lot of times we're not really doing an apples to apples comparison when we say that it's not quicker. There are some instances too where it legitimately is not quicker to do it in an automated fashion than it is manually. Those times are rare, but they do exist. But here's the gotcha on that is, even if you have a radio that takes just as long to automatically align and test as it does to manually align and test that radio, while the 8800SX or 3920B is going through Autotest and doing all of that work for you, you can be like this guy, kick back and relaxing, or that higher productivity thing kicks in. Well, we can go program other radios. We can go update firmware in other radios. We can do repairs. Maybe we've got a box of radios that has broken switches on it that we need to replace. We can go through and do that while that automated test and alignment is occurring. So even in those situations where it's not quicker, which again is kind of rare, but even in those situations, we're able to multitask now, where before we would be chained to the bench in front of that one radio doing that one thing all day long. So higher productivity, more efficiency is key there. And this is something that I think is worth noting. It's not so much, well, I don't know, I guess it is maybe a benefit, but I put it in here more as a key qualification for automated test and alignment. Something that we want to consider when we're looking at test equipment and how we're going to test radios. If we're looking, it's a natural progression right now to move toward automated test and alignment. So that's kind of a given. But even beyond that, one of the things that I think it's important to look for is OEM approval. So what I mean by that is, if we're using an automated test and alignment solution, is it something that the radio OEM has actually looked at and approved it and said, yes, this is the way we want our radios to be tested in order for them to work optimally? And if we don't have that approval, why don't we have that approval? Why, if we're looking at an instrument that doesn't have that OEM approval, why not? Are there deficiencies in the test set? Are there deficiencies in the test algorithm? What's the reason for that? And so, I think it's important to be able to go back. And I talked about the documentation earlier, being able to say, this is the test results for a given radio, and we can look at that and say, yes, everything passed. Having that OEM approval of that automated script, I think, kind of does the same thing for a user, a technician, to be able to go back to their customer and say, you know, not only did we test it, but I mean, this is the way the OEM wants it tested, and you know, if the OEM has approved that, then that means it does what the OEM wants it to do. So, you know, when you go to your customer and say, look, I'm aligning these radios, you can say, I'm doing it correctly because the OEM said you were. Okay. Last thing I want to talk about today is remote monitoring. You know, and one of the things we were talking earlier about coverage, we talked about being able to verify coverage in an area. Remote monitoring kind of gives us one more step closer to, I guess perfection in terms of being able to prevent those types of problems, or at least if a problem does occur, being able to fix it quickly. You know, frequently, you know, I don't know how many times we've been in situations where we're dealing with some sort of problem, and maybe it's at a site that's a 3-hour drive, or maybe it's at a site where it's a 3-hour hike to get to that tower, and you get there and things are back to normal. Maybe it's an interference issue. Maybe it's you know, some sort of intermittent power thing, or maybe it only happens when it rains. Situations like that where you know, it's not a constant, it's not a hard fault in particular. Remote monitoring gives us the ability to kind of monitor that situation in real time from the shop without having to make that drive or hitch a helicopter ride out there, or whatever the case may be. With real-time monitoring, remote monitoring like this, we can actually log into our test equipment and verify what's being reported to us. Sometimes, you know, we're not able to necessarily fix it remotely, but at least maybe we can do some of the troubleshooting you know, while it's failing, and in doing so, have a better idea when we get to the site what it is we need to replace. You know, there's nothing like going out to a site, not knowing what the problem is, knowing what was reported. We get there, the problem's gone, it's working fine now. So what do? We shotgun a bunch of different components out. We swap out radios, we swap out combiners, we swap out duplexers. And in the end, we hope that one of those things was the problem. We hope that we replaced whatever was faulty. If you're not able to verify that, you know, you could be back out there, you know, next week troubleshooting the same problem again. So that becomes costly, both in terms of time, because you had to go out there a second time, but it also becomes a costly event in terms of equipment, because if you're having to swap out whole lots of equipment, you know, that's instead of one component, obviously that's going to be a lot more expensive. And then what do you do with the equipment that you brought back with you? You take that, you send it off to the OEM, you send it off to Depot and say, hey, you know, we believe this failed. They get that equipment back, they test it, no fault found, send it back to you, charge you a fee, and again, that problem occurs next week because you didn't actually catch the right thing. You know, being able to monitor that remotely and identify those faults before you get out there, a lot of times can save you a lot of time and money, because you're able to narrow it down while it's actually happening. One of the other cool things about remote monitoring, and this isn't maybe, I guess, a monitoring thing, but it gives you the ability to collaborate with other technicians. Now, they say a picture's worth 1,000 words, video's worth something more than that. So if they're able to remotely see what you're seeing on your service monitor, they may be able to advise you, again, in real time and say, try this, do this, and see what those effects are. So, you know, benefit in terms of time and money, benefit in terms of having people where they need to be without having to relocate in order to assist each other. It's kind of a win-win. So that concludes our Save Time, Money, and Lives Communication with Communications test webinar. You know, as Sarah mentioned, if you have a question, if you've submitted a question, we will get back to you. I don't know if there's any questions or not. I don't think, obviously there's a couple here. So let me see if I can answer some of these. And again, if there's any that I can't get to, certainly would be happy to get back to you afterward via email or phone call. One question real quick here from Kevin, where can I access the .txt files containing the test results? Within the Autotest system, there is a view results soft key or button on the screen. And if you click on that, you can look at the last results. There's also a browse results on the 8800SX where you can actually scroll and look around for those. On both the 3920B and the 8800SX, there is a copy to USB function. And so we can copy those to a USB flash drive and then take them to our computer. And of course, from there, sky's the limit. You can print them out, email them, whatever, archive them. Like I said, I've got customers that print out all of the results and archive them so that they can refer back to them if needed. But hopefully that answers your question. If not, there's the email address on the on the screen right now. If that doesn't answer your question, drop us an email there, and I will see to it that we get a response to you, and we can walk you through the what you need to do to get there. So I know there's a couple other questions in here. We're past the 45-minute mark that I guess we were shooting for, so I apologize for that. We do also have a number of other webinars that are available for viewing. There's a link on the screen there, that www.viavisolutions.com/RTS webinars. You can go to that webpage, and there's links there to other webinars that we have done that cover some of the things we talked about today more in depth. So we've got webinars up there for site coverage mapping, both indoor and outdoor. We've got auto test webinars out there. We've got webinars out there for just even simply talking about the transition from digital or from analog to digital radios, help you through that process. And once again, if there's any other questions that you have, or if you'd like a demonstration or a quote, please feel free to drop us an email at that email address on the screen there, that avcom.sales@viavisolutions.com, and we'll be happy to get back to you and answer any questions you have, address any questions you have. Please stay online for another minute here. There's a survey at the end of this. But otherwise, thank you for attending. Thanks for joining me today. I hope you have a great rest of your week and rest of your day. Thank you.